A rat that has never met a cat sniffs cat urine for the first time. Instead of running, it walks toward the smell. The parasite is called Toxoplasma gondii. It was discovered in 1908 by two French scientists working at the Pasteur Institute in Tunis, who found it in a small North African rodent called the gundi, which is what the parasite was eventually named after. It is a single-celled protozoan, microscopic, and it has one biological need that defines its entire strategy. It can only complete its life cycle inside the gut of a cat. In every other warm-blooded animal, it gets stuck. A rat eats food contaminated with oocysts shed in cat feces. The parasites multiply. The rat's immune system clamps down on the infection, and the survivors retreat into thick-walled cysts that lodge themselves in the brain and muscle tissue. There they wait. For the parasite to finish its life cycle, it has to get back inside a cat. The only reliable way that happens is if the rat is eaten by one. So the cysts begin to rewire the rat. Healthy rats run from cat odor by instinct. Infected rats do not. In experiments at Oxford in the late 1990s, the parasitologist Joanne Webster found that infected rats placed in arenas dabbed with cat urine sniffed the urine, lingered near it, and in some cases tried to find it. They called the effect fatal attraction. The cysts, although they sit nowhere near the parts of the brain that govern fear, somehow flip the response. The rat's amygdala, the structure that should be screaming run, lights up as if the cat urine were the smell of a potential mate. Dopamine production in infected rats is elevated. Their reaction times are slower. They are easier to catch. From the parasite's perspective, the infected rat is now a delivery vehicle, walking itself toward the host that will let the next generation reproduce. The behavioral change is strangely specific. Infected rats still fear open spaces, still flee from predators they were not engineered for. Only the smell of cat has been overwritten. Humans are not the intended target, but humans get infected anyway, mostly through undercooked meat or contact with cat litter. Current estimates put the global infection rate at around 30% of adults, and in some countries, closer to half. The parasite cannot complete its life cycle in us because a tiger is unlikely to eat any of us in the modern world, but the cysts still settle in our brains and stay there for life. Most carriers feel nothing. Studies by the Czech evolutionary biologist Jaroslav Fleger, going back to 2002, have linked latent infection to slower reaction times, increased risk-taking, and a measurable rise in traffic accidents among carriers. A single-celled organism that needs a cat to reproduce has, by the most cautious estimate, taken up residence in roughly 2 billion human brains. The cat does not need to chase us anymore. We carry the next generation around for them.